In our final example, we're given a situation that has two solutions, and we want to write an absolute value equation that will give us those two solutions. Now, after we write this, we could talk about a variety of different ways that you could change it so that you could create a different equation that would still have those same solutions. But that's not really the intent of this. We want to try to make the simplest equation that's going to have the answers of 5 and 8. And really the easiest way to do this when working backwards is to imagine what this would look like on a number line. So before we do that, let's go back to our original example. If you're looking at this original example and thinking about the absolute value of x equaling 3, we went 3 units out from 0 this way and ended up right there. And we went 3 units out from 0 to the left and ended up right there. You could think of this as being the center. The absolute value, the regular old absolute value operation, grouping symbol, function, whatever you want to call it, is originally centered at 0. And those distances that we found to the left and to the right are based off of this number right here. If we go back to our example and we imagine a number line, and over on the left, here's 5, and over on the right, it's 8. Any algebra student, any kindergartner could probably tell you that the number 0 is not going to be between 5 and 8. So my center is no longer at 0. My place that's in the middle is no longer at 0. So I need to adjust for the fact that my center is no longer at 0. In order to do that, I need to figure out where my new center is. And my new center is right in the middle of those two solutions. A little bit of careful arithmetic, a little bit of finding averages, a little bit of thought. You get that the center place of those 2 points, the center of those 2 points is 6.5. Because the new center is at 6.5, I can now look at those two distances this way and this way. And you might remember that in our previous example, the one that said the absolute value of x is 3, this number was the distance from the center. That number was our distance from the center. 3 and -3 were 3 units from that middle 0, but we don't have the middle 0 anymore. But that doesn't mean that we can't still use that logic. So I know, because this distance is 1.5 and this distance is 1.5, that 1.5 is going to sit over here. Now, that doesn't help me necessarily. That's not the finish of the equation. Because if I looked at this equation, I would say my two solutions were 1.5 and -1.5. And that's not what's happening here. My two solutions need to be 5 and 8. All this number does is this number sets the range. That number sets the range of any absolute value equation. It tells you how far from that middle you need to go. And the key to shifting the space is what actually goes inside with the x. If I want to shift the solution space one way or the other, one direction or the other, I need to shift it so that that center, that 6.5, ends up becoming part of the equation. And the way to do that is imagine that shift as a subtraction. So the final result looks like this. And if you're wondering, well, does that give me the solutions I need? It sure does. Imagine that this absolute value equaled 1.5. I'd add the 6.5 over, that makes 8. Imagine it equaled -1.5. Add the 6.5 over, it makes 5. So when you get generic absolute value equations that look like this number is setting the distance. It's setting how far apart the region needs to be, or how wide the region needs to be, excuse me. This number is setting where the center would be. If you need the center to shift left, as you might imagine, this would just change to a plus. But if you're shifting that space to the right and you're getting a new center that's in between your two solutions, then you're going to subtract on the inside. And you can do this with any two numbers. Let's take two solutions that are over on the right side, since that's the one we just talked about. Let's imagine two solutions, 10 and 26. So I imagine 26 here. I imagine 10 way down here. I need my center, which would be halfway between 10 and 26, which is 18. I've got a distance here of 8. I've got a distance here of 8. 8 sets the stage for the range. And there's my shift of the center. And as I mentioned very briefly before, we could do anything we want to this and still have it have the same solutions, as provided that we do it to both sides. So another equation that would have this same two solutions would be this. I double the left and double the right. Because if I went to solve that, what's the first thing I would do? I'd divide by 2. And I would end up back where I was. So no, this is not a unique solution, but that's certainly the manner in which we can create an equation that gives us two particular solutions.